Here I'm going to talk about the properties of logarithms. These are important because they really help us when we need to solve different types of problems involving logarithms. In the first case, let a be a number that's greater than 0 and not equal to 1, and that way we can talk about it being the base of a logarithm. Okay, so the first part of property 1 says log base a of 1 is equal to 0, and log base a of a is equal to 1. So more specifically, for example, log base 2 of 1 is equal to 0, and that's because 2 raised to the 0 power is equal to 1, and log base 2 of 2 is equal to 1 because 2 raised to the first power is equal to 2. Okay, the second property says this. If you're adding two different logarithms with the same base, then it's equal to the log with that same base of the product of the insides. Okay, so here m and n are required to be positive numbers. So let me show you a specific example of this one. Okay, log base 4 of 2 plus log base 4 of 8. These two logarithms have the same base. So what I can do is I can say that they are equal to, again, log base 4 of 2 times 8. So that's log base 4 of 16, and that's equal to 2 since 4 squared is 16. Okay, the third property says that if you subtract one log expression from another when you're using the same base, it's equal to the log with that same base of the first inside divided by the second inside. Okay, so this quantity divided by this quantity. So for a more specific example, let's take a look at this. Log base 6 of 12 minus log base 6 of 2. Well, that's going to be log base 6 of 12 divided by 2. So that's equal to log base 6 of 6. And we know from property 1 that this is equal to 1. Okay, the last one says that if you're taking the logarithm of a power of some number or some quantity, then what we can do is we can bring that power down out front. So log base a of m raised to the r is r times log base a of m. Okay, here r is any real number. Okay, so any real power of the number m. So for example, log base 1/2 of 2 cubed is equal to 3 times log base 1/2 of 2. Okay, so just take this 3, bring it out front. Log base 1/2 of 2 is equal to -1. So this is equal to 3 times -1, which is -3. Okay, in class we'll discuss why these properties are true. Right now I'll show you how to use them for more complicated problems. Okay, let's expand this here. So we're first going to take care of the multiplication. So we have x times the quantity x plus 1 squared. So that's log base 4 of x plus log base 4 of x plus 1 squared. Now we take care of any exponents. 2 here is an exponent, and so we can bring it down front by property 4. So we get log base 4 of x plus 2 log base 4 of x plus 1. So it's completely expanded now. We can't use any more properties to rewrite it. All right, I'm going to give you a couple to try. Okay, press pause while you expand these two. Okay, for the first one, you should have gotten 2 times log base 3 of x plus 3 times log base 3 of 2x minus 3. For the second one, you should have gotten the natural log of x plus 4 plus the natural log of x squared plus 5. Note that we can't take this 2 and bring it out front because the entire inside has to be raised to the second power. This this would have to be written as x plus 5 quantity squared in order to bring the 2 out front. Okay, let me give you another challenging one to work on. Okay, press pause while you think about this one. Okay, the first thing that I'm going to take notice of is the fact that we have the logarithm of a fraction. So the first step in rewriting it is that I'm going to take the log of the top minus the log of the bottom. Now I'm going to go to each individual piece and simplify as much as possible. This one's completely taken care of because there's no product and no overall power in this piece, in this inside. But in this case, we have x cubed times 1 minus 4x. So that's going to be the log base 7 of x cubed plus log base 7 of 1 minus 4x. Okay, now this log term here is simplified. We can't rewrite it anymore. But in this one, we have an exponent of 3 inside, so we can bring that out front. Okay, so this here is the final answer. Right, I'm going to give you one to try on your own. Okay, press pause while you work on this one. So you should have gotten log of x plus log of x squared plus 3 minus 2 times log of x minus 3. Again, we can't bring this 2 down because it would need to be x plus 3 quantity squared. You can't bring down an exponent if it's just being applied to a term in a sum. Okay, let's condense this logarithmic expression. So by condensing it, what we want to have in the end is just one log of one big inside function. The first thing that we need to do is we need to pop up all of the coefficients, turn them into exponents. Okay, we only want to have a 1 or a negative 1 in front of the logs. Okay, so here that's a 1, that part's okay. This 2 here, we want to pop it up as a power of 2 on x minus 4. And this 5 here, we want to pop it up as an exponent of the x plus 2. Okay, now we want to think backwards. If we have a plus in front, like joining these two terms, it means that in the original logarithmic expression, x was being multiplied by x minus 4 quantity squared. Because of this minus here, we know that this term was in the denominator. So essentially, every log that has a plus in front of it, the term inside is multiplied together to form the numerator. Everything that has a minus in front of it goes together as products in the denominator. So this is equal to the log base 3 of, this first term has a plus in front, so I put an x. The next one has a plus in front, so I do times x minus 4 squared. And this log has a minus in front of it, so x plus 2 to the 5th goes down in the denominator. Okay, and we can check our answer by just expanding this. So it would be log base 3 of x plus log base 3 of x minus 4 squared minus log base 3 of x plus 2 to the 5th. Okay, so once again, whatever has a plus in front of it is multiplied in the numerator. Whatever has a minus in front of it goes down into the denominator. Okay, that's the easiest way to think about this. All right, I'm going to give you one to try. Okay, press pause while you work on this one. Okay, the first thing that you wanted to do was you wanted to pop up all of the coefficients as exponents so that we only have either 1 or negative 1 in front of the logs. And then the next thing you do is combine everything into one single expression. So the terms that have a plus in front of the log form the numerator. Okay, we multiply the insides together. And whatever has a minus in front goes to the denominator. Okay, x cubed comes down here into the denominator.